this is going to be a challenge. I gave you the equation, but I want you to transform this thing right on the grid. Oh my goodness, how am I going to do this? Actually, really quite easily. What you do if you're asked to transform something on a grid, just go out and take a look. Look, pick some real nice points, like that one. That's 3, 0. That one looks almost like 2, -4. There's another beautiful point. There's a pretty point. There's a pretty point right there. And lastly, there's a point, and if you want, you can throw another one on there, but I think that's probably going to be enough. Now, what you want to be able to do is, here's that graph, but what I want you to see here is what is the transformation. It's a horizontal. It's, number one, it's going to be flipped, and number two, it's going to be multiplied by a scale factor of 3. So we can actually put the scale factor, we can actually put the reflection in the scale factor right now and call it a -3. So take every one of those points. Let's start with this one right here. So there's no vertical stretch here. It's only horizontal, and it's by a scale factor of -3. Okay, so let's take this one. That's 3. Scale factor of -3 means it's going to be a -9. It's going to land way over here. Boom. Okay, now what's the next one we're going to look at? Let's look at this point right here. This, of course, horizontally is 2. Don't get it confused with a vertical one. We're doing a horizontal, not a vertical. So horizontally, that's 2 times by -3 gives me -6. So it's going to land up way, way, way over here. Look how it's still in the same plane, same -4, but now flipped to the other side and stretched. Okay, now let's go pick another color. I'll pick blue for this one. Look at this guy. This is at 1. Multiplied again by -3. This now becomes -3, way over here. Beautiful. So far, if you think about it, with those 3 points, what do I have for a graph? Well, originally this was going up this way and then coming down and going around like this. Okay, so now it's flipped. It's up this way, cut around, and doing that. So I'm right up to that point now. Okay, let's do the rest of this. Oh, this is fun. Okay, here we go. This is at 0. This is right here. This point is at the 0 mark. So 0 times -3 is, guess what? 0. So this graph now still stays the same. It's an invariant point. And if you remember when we talked about invariant points, we even said invariant points on the axis is, aha, really cool. So this guy's going to come around here like this, come up this way, and looks like it's going to go out here. Ooh, that's an awful looking line. Let's see if I can clean that up a little bit. Oh, that looks terrible. Okay, up around this way, kind of like that. Okay, so it's going to come up to this point here, but what's going to happen to this guy here? Okay, this guy is at -1 times the -3 is going to be +3. Oh my goodness, so this guy's going to actually come around this way to +3, which is right here. So it's going to come around this way and do that, starting to buckle down right about there, it looks like. And then finally, look at this guy right here. At -2 times -3 is going to be 6, way the heck out here, and it's just going to come barreling down that way. So look at the kind of graph that we have. We have a graph coming around this way, going up this way. Here's our horizontal stretch done right on the graph. And we threw in a reflection just for good measure. Holy smokes, look how pretty that is. My goodness gracious me, that looks gorgeous. Okay, so with that in mind, let's answer the rest of the questions. It says write an equation now that represents this. Oh my goodness, how are we going to do that? Well, remember our original equation was x cubed minus 2x squared minus 5x plus 6. I'm going to see if I can grab this thing. I can. I'm going to bring them all the way down here. Okay, so that I don't have to fight in terms of remembering how to do that one. Here's my graph right here. Okay, so let's bring it down. Remember what this means. This means to substitute every x now gets a -1/3. So this is now -1/3 x cubed minus 2 times minus 1/3 squared minus 5 times minus 1/3 plus 6. Interesting. Okay, let's go out and let's solve this. Minus 1/3. So minus times a minus is a positive times a minus is a minus. 3 times 3 is 9 times 3 is 27. So that's 1 over 27, right? Okay. That still is got the x there. Don't forget, we have an x there, so that's still x cubed. This guy has got an x here. Okay, don't forget, that guy had an x here. Why? Because it's minus 1/3 x minus, okay, this one's going to be tough. This is going to be minus 2 times 1 over 3 squared is going to be 1/9. Negative times a negative is a positive, so this is 1/9 x squared. This is going to be minus 5 times, okay, oh, there's nothing here. Oh, okay, so I'm just going to leave it as minus 1/3 x. That's fine. Plus 6. Okay, let's clean this up. Oh, my goodness, I'm having fun with this. All right, here we go. So this is minus 1/27 x cubed. Minus 2 times 1 is minus 2/9 x squared. Minus 5 times minus 1/3 gives me plus 5/3 x plus 6. There's our new transformed equation. Oh my goodness. Holy smokes, does that look ugly? Okay, anyways, compared to the graph of f of x, okay, our first function, the graph of this new function, f of negative 1/3 x, results in a what? Horizontal, you're right, horizontal stretch about, okay, we're going horizontally, so here's our axis. There's our x-axis. We're going horizontal. That means we're going over the y. So it's a horizontal stretch about the y-axis by a factor of how much? 3. Together with a reflection in the, yep, you're reflecting over the y-axis. You got it. Wow, that is just so cool. What a tremendous question.